Welcome back to your trigonometry lecture videos. I hope that your first homework assignment went smooth and easy and that you're ready to build on that foundation. In section 1.2, we'll learn about radian measure, arc length, and area. In 1.2.1, we're going to focus on a new way of measuring angles, not in degrees this time, but in radians. Let's begin with the definition. The radian measure of an angle alpha in standard position is the directed length of an intercepted arc on the unit circle, whereas an angle measured in degrees is a measure of the amount of rotation around a circle. The measure of the angle in radians is a length. In particular, it's the length of the arc intercepted by that angle on the unit circle. A unit circle is a circle of radius 1. So all radian measure will be relative to a circle of radius 1. Notice that this is a directed length. That simply means that if we're going in the counterclockwise direction, we're considering a positive angle, and if we're going in the clockwise direction, it's a negative angle. So the sign attached to the length is simply indicative of direction. Radian measure is dependent on a unit circle, that is a circle of radius 1. Since we're considering the measure of the angle as an arc length, imagine a circle of radius less than 1. Notice that the length of the arc on a circle less than 1, subtended by the angle alpha, is less than the length of the arc subtended by the same angle on the unit circle. Or if we consider a circle of a radius larger than 1, then we can also observe that the arc length on that circle of larger radius is larger than the arc length subtended by the angle alpha on the unit circle. Therefore, radian measure is always relative to a unit circle. Everything is normalized to the unit circle. In that normalization process, we do lose units, so a radian measure is a unitless measurement. More on that in section 1.2.3. For now, let's make some observations about radian measure. Now, the circumference of a circle is given by the formula 2 pi r. If we're specifically considering the unit circle where the radius is 1, then the circumference of the unit circle is 2 times pi times 1, or 2 pi radians. So the distance, if we were to measure the circumference of the unit circle, the distance of that circumference would be 2 pi radians. Pi is approximately 3.14, so 360 degrees around that circle is approximately equal to 6.28 radians. Halfway around the circle then, that arc length would be pi radians, or approximately 3.14. If we divide that in thirds, then 1 radian looks approximately like angle alpha that we have constructed here on the unit circle. Remember, 1 radian is measured in the positive direction, whereas negative 1 radian is measured in the clockwise direction. So degree measure is generally used in areas such as navigation, surveying, and engineering. And we'll talk about a lot of problems that use degree measure for angles. However, radian measure is extremely beneficial in simplifying formulas in trigonometry and especially derivative and integral formulas for calculus. So for that reason, we will practice problems that require us to deal with angles in degrees and also in radians. In the next video, we'll consider how do we convert between degrees and radians.